In this video, we're going to learn how to rewrite an integer as a product of prime factors. And we're going to start with 3,960. The way we do this is we test to see which integers will go into 3,960. And the prime numbers we work with, the first few are 2, 3, 5, 7, 11, 13, 17. This should get us through this problem. Remember, prime numbers are numbers that are only divisible by 1 and themselves. So I'm going to start with the smallest prime number, 2, and I know 2 goes into 3,960 because 3,960 is an even number, and 2 goes into that 1,980 times. And you can use your calculator if you need to. Again, that's another even number. I know 2 goes into 1980, and 2 goes into 1,980, 990 times. That's still an even number, and 2 goes into 990, 495 times. Well, 495 is an odd number, so I know 2 won't go into it. So I'm going to use a trick to determine whether I can divide it by 3. So taking a look at it, I see that 4 plus 9 plus 5 adds up to 18. And I know that if the sum of the digits is divisible by 3, then the number itself is divisible by 3. I know I can divide 18 by 3, so I can divide 495 by 3. That goes into that 165 times. And when I add the 1, the 6, and the 5, I get 12. So I know 165 is also divisible by 3. And 165 divided by 3 is 55. 5 and 5 is 10, not divisible by 3. So I go up to the next prime number, and that's 5. 55 divided by 5 is 11. 11 is a prime number, so I take that and move that number right underneath all the other prime factors. So I can say 3,960 is the same as or equals 2 times 2 times 2 times 3 times 3 times 5 times 11. And if you were to put those in your calculator, you would see that that's true. Now let's try a really big number, and I'm going to have to get out my calculator to do this one. So let's prime factor 8,644,075. Again, I'm going to write my list of prime numbers down here, at least the first 10 or so. So my prime numbers are 2, 3, 5, 7, not 9 because it's divisible by 3, 11, 13, not 15, but 17, and 19, not 21, but 23, not 25 or 27, but 29, 31, and we'll see where that gets us right now. Okay, so those are our first few prime numbers. Now, let's try this out. I know that 8,644,075 is not divisible by 2. Is it divisible by 3? So 8 and 6 is 14, 18, 22, 29, 34. 34 is not divisible by 3. So 8,644,075 is not divisible by 3. I can tell by looking, however, that it is divisible by 5. So let's divide it by 5. So I'm going to type that in. Calculator, divide by 5. So that's 1,728,815. So let's write that down. 1,728,815. Which I can also tell is divisible by 5 because it ends in a 5 or a 0. And if I divide that by 5, I get 345,000 763. and I can tell that that is not divisible by 5. Then I need to go check whether I can divide it by 7, and I can't divide it by 7. Then I check to see if I can divide it by 11, and I can divide that by 11. And 11 goes into 345,763, 31,433 times. I try 11 again, and 11 doesn't go into that. Then I try 13, and 13 doesn't go into that. And then I try 17, and 17 works. And I find that 17 goes into 31,433 times, 1,849 times. So 1,849. Again, 17 goes into 31,843, 1,849 times. Then I check to see whether 17 goes into 1,849, and it doesn't. Then I try 19, and I try 23, and I try 29, and I try 31, and I have to go all the way up to 43 before I find a prime number that goes into 1849. And it so happens that 43 goes into 1849 43 times, and 43 is prime. So I'm going to move that over here underneath my other prime factors. So now I know that 8,644,075 is the same as 5 times 5 times 11 times 17 times 43 times 43. And if we want to show that's true, you can go ahead and plug those numbers into your calculator and prove it to yourself. Now, armed with this, you should be able to complete all the factoring exercises on this week's review.